Hi everyone, welcome back to Geeks for Geeks. So today we are discussing about the weekly coding contest and we have the first problem name is disk placement. So let's quickly have a look on the problem statement. So you are given n disk and your task is to split them between two stands or towers such that the product of the number of disks in each tower is maximized. Formally, if the first tower contains A disk and the second tower contains B disk, you need to maximize the product A into B where A plus B equals to n. Okay, so this is the problem statement. Let's try to understand the problem by looking at the example number one. So we can see that at example number one, I have been given n equals to 7. It means that I have some 7 disks and I have to place them in two towers so that the value or the product of these values should be maximized. Okay, so we have these such 7 disks. So what can I do is I can place one disk in one tower and remaining 6 disks in another tower. So one case can be like this. So we have 6 disks in this tower and we only have one disk in this tower. So what does our question ask? So our question asked about the value of a plus a into b. So what is the value of a into b? So one here is a and b value is 6. So a into b will be 6 into 1, that is 6, right? So for this configuration I have the value of the product as 6. So let's try to understand what is given in the example output. So output is 12. So how it is 12? So it is taking 4 disks in one tower and 3 disks in another tower. So what is the product of A into B? So A into B will be 4 into 3, that is 12. So that's why my answer for n equals to 7 is coming out to be 12, and this is the maximum value I can make from n equals to 7. Also I have to keep one thing that a plus b should be equals to n. So the number 1 and the sum of the number 1 and number 2 should be equal to the original number, that is n. So now let's see how we can find the solution. So our solution lies to get the maximized value. I have to reduce the difference between the value of A into B. Okay, so I have to find out the value of A into B and I have to maximize this. So to maximize this, I have to decrease the difference of A and B. So how can I decrease the difference of A and B? So what can I do is, let's say I have n. So I can take n by 2 as A and also I can take n by 2 as B, right, if n is even. So what is the difference between A and B? So we can see that A minus B will be 0, right? So A minus B will be 0. So when n is even, how can I split my number? So I can split the number in n by 2 and n by 2. By this way, the difference between the value of A and B will be minimized. Okay. Now what if n is odd? What if n is odd? So I can do the split like this. I can say that a value can be n by 2 and the value of b can be n by 2 and plus 1. N by 2 and plus 1. And what will be the difference here? So the difference between a and b will be 1. So can we decrease this difference by anyhow? No, we cannot decrease because the value here of n is odd, and if I try to divide this odd number, so one number will come out to be odd and one number will come out to be even. So the difference between odd and even number cannot be minimized by 1. So that's why one number is n by 2 and the second number is n by 2 plus 1. So basically, if given value is n, then how can I find out the solution? So if n modulo 2 is equals to 0, that is the given number is even. So what can I do? I can just simply return n by 2, that is the value of a, also into n by 2, that is the value of b. Else what I have to do is I have to return n by 2, that is the value of a, into n by 2 plus 1. what is this n by 2 plus 1? This is the value of b, right? So that is the solution. Now let's look at the coding part. So I I have been given the function name as max product and I am receiving one integer n value. I am taking two values p and q. So basically p and q are denoting value of a and b. So if n modulo 2 equals to 0, it means that the given value of n is even. So how can I divide this n? So I can divide this n into two equal parts, that is n by 2 and n by 2. Else, if the value of n is odd, how can I divide them? So I can divide them into one even part and I can divide them into, and the second part will be the odd part, right? So that's why p is equals to n by 2 and the value of q is n by 2 plus 1. And in the end, I am just simply returning p into q. That is the answer for this question. Okay, so let's try to compile and run this code. Okay, so it's passing the visible test cases. Now let's try to submit. Okay, so it is passing on the hidden test cases also. So what will be the time complexity here? So we can see that we are not we are doing just constant operations in the whole function. So we can say that the time complexity would be big O of 1. Also the space complexity would be also big O of 1. So time and space complexity would be big O of 1. That is constant, right? Now I'll move to the next problem, which is named as maximum sum. Okay, so let us try to read the problem statement. You are given an array ARR of n integers and where n is the length of the array, and your task is to find the maximum sum of two distinct numbers from the array such that for a given bit position x, the xth bit of one number is set, that is equals to 1, and the xth bit of the other number is unset, that is the value 0. If no such pair of distinct number exists where one has the xth bit set and other has the xth bit as unset, so I just have to return the -1. So let's try to understand this problem statement by the example number 1. So we are given an array, and what are the array values? So 1 5 9 2 3 1 2 1 5 9 2 3 and 12, right? So let us try to write the binary representation of every number. Okay, so we have written the binary representation of every number. So in the question, we are also given the value x, and here what is the value of x? So x value is 3. So what does our problem statement says? So we have to find out two numbers, such that their xth bit from the right side, they are denoting from the right side. So the xth bit of one number, let's say I am assuming the number a and number b. So the xth bit of a should be set, means xth bit should be 1, and for the b, xth bit should be 0. So I have to find out these two numbers from the given array, and I have to find out the maximum value of a and the maximum value of b, and they should be distinct. So in this example, I have given the answer as 9 plus 23. So we are taking 9 as our one number and 23 as our second number. So let's see what is the xth bit of 9. So we can see that this is the first bit, this is the second bit, and this is the third bit of 9. So we can see that the value of b in the given example is 9 because the xth bit is unset. Okay, and what is the value of a? So the value of a is 23 because xth bit is 1, that is set. So we have to find out such values of a and b, and the value of a and b, these should be maximum. Okay, so we have to return the sum of these two values, that is sum of a and b. So what will be the sum here? And we can see that value of a is 23. So 23 plus 9, so it will be 32. That is the answer for our test case number 1. Similarly, if we don't find any such value, we can see that in the example number 2, we are given 1 1 1, and I have to find out two distinct values. So it is given in the problem that we have to find out two distinct values, and they should not be same. And we can also say that we can also see that two same values will not have different bits representation. Okay, so in the example number 2, there is no value or there is no pair, so that's why our answer is -1. So if there are no such pairs, so we have to return a -1 here. Okay, so let's discuss the solution for this problem. What can I do is I can just simply find out the binary representation of every number, and I can take one variable, that is a, which will be storing the value of the number which has the accept bit as set, and I will also take one variable, that is b, which will be storing the value of the number that has accept bit as unset. Okay, so what we will do, so first of all we will try to find out the binary representation, and after that I will run a for loop, or I will iterate over the array which is given to me. So here I am standing at the first index or the first element. So what is the binary representation of 1? We can see that binary representation of 1 is simple 1. So what is the xth bit? And we have x as 3, right? So what is the xth bit from the right side? So we can see that xth bit is 0, means unset. So I will store this value in my b variable, because the value of b is -1 initially, and also the value of a is also -1. So I have got the value which has the xth bit as unset, and also it is greater than the previous value. So what I will do, I will replace the value of -1. So I will add 1. So now my variable b will be storing the value of 1. Okay, now iterate over the now move to the second element. So what is the second element? We can see that second element is 5. So what is the xth bit from the right side? We can see that xth bit from the right side is 1. It means that the number 5 has the xth bit as set. So what I will do, I will try to find out. Okay, so what I will do, I will store the value in my a variable, because the value of a previously is -1, which is lesser than 5, and also the 5 has xth bit from the right side as set. So I am storing the value that in my a variable. So I have got a new value which is greater than the previous value. So I will just replace the value of -1 with 5. Right. Now move to the next element. So the next element is 9. So what is the xth bit from the right side? We can see that xth bit from the right side is 0. So I can say that I will replace the value of b, that is 1, with 9, because I have got another bigger value that has the xth bit as unset. So I will just simply replace the value of 1 with 9. Okay, now move to the next element. So the next element is 23. So what is the value of 23? What is the binary representation of 23? This is the binary representation of 23. And what is the xth bit? So we can see that 1 is the xth bit. So I can just simply replace the value of a, that is 5, with the value of 23. Why? Because I have found the value which is greater than the current value of a, and it also has the xth bit from the right side as set. So I have to find out the maximum value. So that's why I will replace the value of 25 with 23. Now move to the next value, that is 13. So what is the xth bit from the right side? We can see that 1 is the xth bit. So I can say that it has the set bit on the xth bit. So now I will try to find out, is the value of a lesser than the value of the current element, that is 13, because I have to find out the maximum values, right? So we can see that 23 is not lesser than 13. So I will not replace the value of 23. Now I have finished the array. So in the end, I will just check if the value of a is -1 or the value of b is -1. So if any of them is -1, it means that I have not found a pair with such condition, that is the xth bit is unset and set. I have not found that pair. So I will just simply return -1, because the question has asked us to return the -1. Else I will just simply return a plus b, because question says that we have to return the sum of these two values. So this is the solution. So now let's move to the coding part. So the function name is maxsum, and we are getting integer n. What is integer n? So n is the size of the given array, and after that I have been given the integer x. So what is integer x? Integer x is the value of x from which I have to find out the what is the value of x. So the value of x is that we have to find out which two numbers has the xth bit as set and unset. I have to find out such two pairs, right? Not such two pairs, such two values. So that value is given to me in integer x, and after that I am getting one array. So array will be storing the values of values, and after that I am making two variables a and b. So initially they will be -1. Why -1? Because I will get the idea after the for loop or iterating the array. If the value of anyone remains the -1, it means that I have not found such two values. So after that I am iterating on my array, and I am finding out the binary representation of every number. So this bit set will find out the binary representation of every number. For example, I am writing like this: bit set 32, and I am writing binary, and I'm passing the 5. So what it will do, it will find out the binary representation of 5, and it will give me one array. And what is the size of the array? So the size of the array will be 32. Okay, so it will store the binary representation. So the binary representation of 5 will be stored in this bit set array whose name is binary. Okay. Now at line 31, I am finding if binary of x minus 1 equals to 1. So what this line will find out? We can see that the value of x is given as 1 based indexing. So to convert that 1 based indexing as 0 based indexing, I am subtracting -1. And if binary of x minus 1 equals to 1, it means that val has xth bit as set, because the value is 1, right? Xth bit as set. So in which variable I am storing the value of the set bit? So I am storing that value in my a variable. So now after, if this value or if this condition is true, at line 32 I am finding out if the current value is greater than the previous a value. Why I am doing this? Because I have to find out the maximum value of a and the maximum value of b. So if I have find out another value which is greater than the previous value, and it also has the xth bit as set, so why don't we take that? We will take that value, right? So that's why I am doing, if val is greater than a, then do a equals to val. So the current value will become the value of a. Similarly, in the else part, so if the binary representation or the binary array has the value of x minus 1 as 0, it means that the xth bit is unset. So in which variable I am storing that value? So I am storing that value in my b variable. So that's why I am going in my else part and checking if val is greater than b. It means that I have find out one another value that has the xth bit as unset, and what I will do, I will just simply replace the value of b as well, because I have to find out the maximum value, right? Now in the end, after my for loop is finished, I am just checking if a remains -1 or b remains -1. So if any of the value remains -1, it means that I have not found two such values. So just simply return -1, else return a plus b, because the questions because the question has asked us to return the sum of these two values. So let's try to compile and run this code. Okay, so it's passing on the visible test cases. Now try to submit this. Okay, so it has also passed the hidden test cases. So I hope you got the solution. Okay, so now let's move to the next problem. So the problem name is get count. Now let's try to read the problem statement. So we are given a tree rooted at node 1, where each node represents a city in an empire. Okay, so we are given a tree whose root node is 1, and each node represents a city in an empire. The king want to identify pairs of cities for constructing castles based on the sizes of their subtrees. Okay, so the king want to identify the pairs, so it means that we just have to like find the number of pairs of cities for constructing castles based on their sizes of their subtrees. Okay, so what is the condition? So the king wants to identify the pairs on the basis of their size of the subtrees. Okay, specifically you need to find the number of pairs of cities A comma B such that the subtree rooted at city A contains exactly X cities. The subtree rooted at city B contains exactly Y cities, and they both are including in that X cities and Y cities, right? Your task is to count the number of valid pairs A and B where city A has a subtree of size X and city B has a subtree of size Y. So this is the problem statement. So let's try to understand problem more by looking at the example number 1. Okay, so this is the example number 1 and we are given the value of n as 8. It means that there will be n nodes. There will be 8 nodes, and we are also given one edges array. What this edges array will represent? So it represents that one node has an edge with 2 and one has an edge with 3, 2 has an edge with 4, 2 has an edge with 5, 3 has an edge with 6, 6 has an edge with 7, and 5 has an edge with 8. So if we try to make a tree from this edges array, so I will get this same tree like this. I am also given two values. One value is x and the second value is y. So x is given as 3 and y is given as 4. So the output for this particular example is 2. So let's try to understand how it is 2. So the subtree rooted at city 3 contains exactly 3 cities. So let's try to find out the city 3. So this is the city 3, and what is the size of its subtree? So in the problem statement it is given that we have to include the current city, right? So one node is this, the including the city 3 itself, and the second node is city 6 and the third node is city 7. So there are three node, or we can say that the size of subtree of city 3 is 3. Okay, and what is the second city which is given to us? So the second city rooted at city 5 6 contain exactly two cities. So let's try to find out which is the city number 5. We can see that this is the city number 5, and how many nodes are connected to city number 5? So 5 is connected and 8 is connected, so there are two cities which are connected to 5. It means that 5 has a subtree size as 2. So also 6 has a subtree size as 2 because 6 is we have to include the current node and we have to include the uh, children node, that is 7. So 5 and 6 have 2 size subtree, and city 3 has 3 size subtree, right? So we can see that I have to find out the number of pairs in which one city has x size subtree. So here x is 3, so we can see that I have found one city with x size subtree. So what is the second thing? So the second thing is that I have to find out the city with two size subtree. So we can see that I have two cities whose subtree size is 2. So we have one city with three subtree size and two city with two subtree size. So how many total number of pairs will be there? So to find out the total number of pairs, we will just multiply them. Also, we can find out the possible pairs like this. So one possible pair will be 3 comma 5 and the second possible pair will be 3 comma 6. So how can we find out the total number of pairs? So just simply multiply these values. So the answer will come out to be 2. So this was the example number 1, and let's see the example number 2 also. So we are given n equals to 5, and if we try to make the tree from this edges array, I will get the same tree here. And we have to find out the city which has the subtree size as 3, and I also have to find out the number of cities which has the subtree size as 1. So we can see that the subtree rooted at city 2 contains exactly 3 cities. So we can see that this city 2 has a subtree size of 2, has a subtree size of 3. Why 3? Because we have to include the current city. And what are the child cities? So 4 is the child city and 5 is also the child city. So how many cities are connected to 2? So we can see that 3 cities are connected. It means that city 2 has a subtree size of 3. And is there any city which has the same subtree size? No. Now let's find out how many cities are there with subtree size as 1. So we can see that there are 3 cities with subtree size 1. What are these cities? So they will be the leaf nodes because they are not connected to any other node. So they will be only considered for the subtree which has size 1 because 4 is not connected to anyone. That's why 4 is the only node or only city that is connected. Similarly for 5 and similarly for 3. So we have 3 size subtree and one time, and we have one city which has 3 subtree size. Okay, and we also have got 3 cities which have one subtree size, right? So how many total number of pairs there will be? So to find out the total number of pairs, what we have to do? We just have to multiply their counts. So 1 into 3, so there will be 3 total number of pairs. We can also find out manually, like the city 2 has a subtree of size 3 and city 4, 5 and 3 has a subtree of size 1. So if we try to find or make the pairs, so one pair will be 2 comma 4 and second pair will be 2 comma 5 and the third pair will be 2 comma 3, right? So the total number of pairs are 3, so that's why the answer here is 3. So this was the problem statement. I hope the problem statement is clear to you guys. So now let's move to the solution part. So the first step in the solution will be to make tree from the given edges, because we are given the edges in my edges array. So the first step is to make tree from the edges array. So this is the first step. Now what we can do? So the second step can be, we can write some recursive function. What this recursive function will do? It will return me the size of the subtree of that tree. What will be the second step? So the second step will be, I will be writing one recursive function, and that recursive function will give me the size of its subtree including the current node itself. Okay, so recursive function, what does this recursive function will return me? So it will return the size of its subtree. It will return the size of its subtree including the current node itself. So let's try to understand this thing by taking one example. So we will take the same example, 1, 2, 3, 4 and 5, right? So I will write a recursive function that will find out the number of the size of its subtree. So for example, I am at city 2. So I have called the recursion on its children. So what they will return to me? So this 4 will return the size of its subtree. So what is the size of its subtree? So the size of subtree is 1. So 4 will return 1 to the 2, and also 2 will call 5. So what will 5 will return? So 5 will return 1 because it also has the subtree size as 1. Now 2 has got 1 from the left side and 1 from the right side. Also I will add a plus 1 because of the current node itself. So we can say that 2 has a subtree of size 3. Okay, now what can I do is I can maintain one counter variable that will count the number of subtrees whose subtree size is x. So I can maintain one count x variable. So what this count x variable will store? So it will store the number of subtrees that has the size of subtree as x, which is given to us in the problem statement. So here x value is 3 and y value is 1, right? So we can see that city 2 has got the subtree size as 3. So I will increase the value of counter by one, that I have got one city that has the subtree size as 3. Similarly, I will also keep one counter x y variable which will be storing the value of 0. So what this variable will keep the track? What does this variable will store? So it will keep the track of the number of subtrees whose subtree size is y, that is given in the problem statement. Okay, so initially they will be starting from 0. Now let's try to find out how many subtrees are there. So we can see that we have 3 subtrees. So this one and this one, whose size is y, which is 1, that is given in the problem statement. So I can just increase the count of y variable by 3. So I have got 1 and 3. So to find out the total number of pairs, I will just simply multiply them to find out the total number of pairs. So it will come out to be 3. So that's how we are going to write up a recursive function. So now let's try to like try to write some pseudocode. So for example, my function name is f and it will return me some integer variable, and I will get one source node or the node at which I am currently, and I will also get some adjacency array because I have to make the tree from the given number of edges, right? Okay, and yeah. So what I will do, I will make one counter variable, not the counter variable, I will make one size variable, which will be 1 because of the current node. And I will call the recursion on all of its children, that is the source node. Okay, so I am running a for loop. So how can I call? So I can just simply pass IT, because IT is the child that is connected to adjacency, that is connected to source, and I will simply pass adjacency as same. So what does this function will return? It will return the size of the subtree of node or city IT, and I have to just add them or add the size into my size variable because I have to find out the size of its subtree, right? So I am calling on all the childrens. So for all the childrens, I have to add them into my current size variable to find out the size of the whole subtree. Right now, after this line, my size variable will have the size of the subtree for the node src. Right now, I can just simply take one counter, or I can just simply make one if condition, that if size comes out to be x, which is given to me in the problem statement, then I will increase the count of x by 1 because I have got one city whose subtree size is x. And also if the subtree size comes out to be y, which is given in the problem, so I will just simply increase the counter of y. What does this counter of y plus plus will state? So it will state that I have got one another city whose subtree size is y. Okay. Now, in the end, I can just simply return, and I have made these count x and count y variable as global. So they will be initializing with 0. And in the main function, I will just simply return the count x into count of y, because I have to find out the total number of pairs, right? So let's try to see the coding part. Okay, so uh, we have the function name as get count. Okay, so this is the function which is get count, and I am getting the value of n, which is the number of nodes in my tree, and I am also getting one edges vector of vector. It will store the number of, it will be storing the edges which have, which node has edge with which edge. It will be storing which node has n with which node. Okay, so and we also got the integer x and integer y. Okay, and after this I am making one vector of adjacency, and I am iterating on the edges array. And what I am doing here is I am adding adjacency of edge of 0 dot pushback edge of 1. I am just, for example, I am making the connection like this. Also, 1 is connected to 2. Also, I have to add that in my 2's adjacency also, because 2 is also connected to 1, right? So that's why this is the first thing that is adding. The first thing is being added for the node 1 and the second line is being added for the node 2, right? And after that I am making two integer count x variable that are initialized with 0, and I am calling my dfs function. So what does this dfs function will do? So it will find, or it will return me the size of the subtree of the node. And initially I am calling this on node 1 because it is said, or it is stated, or it is given in the problem statement that I am I have been given the tree which is rooted at node 1, right? So I am passing -1. It indicates that there is no parent of node 1, and I am passing my adjacency array x, y, and counter x and counter y. Now coming to the DFS function, so I am receiving the node and I am also getting the parent variable and adjacency array x, y, counter of x, counter of y. And you can see that I am receiving that counter of x and counter of y as a reference. It means that if I make any change inside this DFS function, that will also reflect in my get count function, because I am taking the reference of their memory, not the copy of their memory, right? So after this, inside the DFS function, I have my subtree size as 1. Why we are initializing it 1? Because I am including the current node. Because I am including the current node, right? After that, I am iterating on all the neighbors of this particular node. So if neighbor is not equals to parent, then I am only calling my DFS function for that particular neighbor, and that DFS function will return me the subtree size of this neighbor. And I have to add that subtree size into my subtree size variable. Why we are adding? Because I have to find out the whole subtree size. How can I find out? So if I get the sum if I get the subtree size of all of its neighbors, then I can just sum up all the subtree size of its neighbors and add a +1 because of the current node. So that's how I will get the subtree size of that particular node. Now after this for loop is finished, I am checking that if the subtree size is equals to x, it means that I have got one subtree. It means that I have got one city which has the subtree size as x. So simply increase the counter x variable by 1. Also after this line, I am checking for the subtree size as y. So if I have got the subtree size as y, then I can just increase my count y by I can just increase my count y by plus by 1, because I have got one city whose subtree size is y, and in the end just return the subtree size, because that's the main motive of our DFS function. Now coming back to the get count function. So after my DFS function is finished, count x will be storing the number of subtrees whose subtree size is x, and count y will be storing the number of subtrees whose subtree size is y. And in the end I can just simply return the count x into count y, because I have to find out the total number of pairs. So I hope the solution is clear to you. Now let's try to compile and run the problem. Let's try to compile and run the code. So yeah, it's passing for the visible test cases. Now let's try to submit. Okay, so it's passing on the hidden test cases also. So let's try to find out the time complexity. So as we are moving on each node at max one time, so suppose there are n nodes, so what will be the time complexity to travel on all these nodes? So the time complexity will be big of n. Why big of n? Because we are traveling on each node by one time. So the time complexity is big of n. I hope this problem is and the code is clear to you. Okay, so now let's move to the next question. So the question name is tree game. Let's try to read the problem statement. So Geek is playing a game involving a tree with n nodes. Okay, so we have a tree, and the tree has n nodes, the tree is rooted at node 1. Okay, so it's given that the tree is rooted at node 1. It's given that the tree is rooted at node 1, and for each node I, the I value belongs to 2 to n. There is an edge connecting it to a parent node p of I minus 1. Each node I also has a certain score denoted as I. Okay, so basically we are given a tree like structure, and the tree is rooted at node 1, and to find out the parent we are also given one parent array. In this game, Geek can choose to remove a subset of nodes, and when a node is removed, all edges connected to it are also removed. Okay, so basically we are Geek can remove some of the nodes, and if we remove any node, then all of the edges which are connected to that particular node are also removed. After the removal, for each remaining node, the number of edges connected to it is checked. Okay, so if we remove any node, then after that we have to check out what are the number of node or the number of edges connected to that particular node. Okay, so if any remaining node has an even number of connected edges, Geek loses the game and the total score becomes 0. Okay, so for if at any particular time the number of edges for any particular node becomes even, then the geek loses the game and the total score becomes 0. If all the nodes have an odd number of connected edges, then geek wins and the total score is equal to the sum of all the remaining score, right? So how can we find out the score? So we will sum up all the scores, and we are given the array which is named as a to find out the score for any node, right? So geek wants to maximize the total score he can collect by optimally removing certain nodes. Okay, so we have to find out what can be the maximum score if we can try to remove some of the nodes from the given tree. Okay, so this was the problem statement. Now let's try to understand the example number 1. Okay, so this is the example number 1 which is given to us, and we have n value as 3. It means that we will be having 3 nodes, and we are also given one p array. So what does this p array will store? It will store the parent of that particular node, right? And after that we are given one a array. So a array will be storing the score of every node, right? So we know that our tree is rooted at node 1, so we will try to make our node 1, and after that from the parent array we will try to find out the parent of each node. So our structure of tree will look like this if we try to find out the parent from this given p array. Okay, so also for every node I have been given this score. So what is the score? So for node 1 I have been given the score as 1, and for node 2 I have been given the score as 2, and for 3 I have been given the score as 3. So now we have made our tree from the given parent array. Now what is the output here? So the output here given is 4. So let's try to understand the explanation how our answer is coming 4 for this particular example, right? So explanation says that if we do not remove any node, node 1 will have two connected edges. So we can see that one is connected to 2 and one is also connected to 3, right? So how many total number of edges are connected from 1? So we can see that there are two number of edges which are connected, and can also see that this number is even. So according to the question, our answer will become 0 because the geek will lose the game here if we do not remove any node, right? So if we do not remove any node, my answer comes out to be 0. Okay, so now let's try to see the second line. So the second line says that if we remove node 3, then node 1 and node 2 will each have one one connected edge. So let's try to remove node 3. So if we try to remove node 3, our tree will look like this. So what will be the total score here? So the total score here will be the sum of all the nodes. So it will be 2 plus 1 because 2 is the score of the second node and 1 is the score of the first node. So it will be 3, right? Okay, so this is the second case, and what will be the third case? So the third case will be the if we try to remove the node 2. So
if remove node 2, so let's try to remove node 2. So if we try to remove node 2, then our tree will look like this: 1 3, and the total score will be 1 plus 3, because this has the score of 1 and this has the score of 3. So total score will be 1 plus 3, that will be 4, right? So in the third line, we are given, so we can see that if we remove node 2, then node 1 and node 3 will each have one connected edge. The score will be 4. So we can see that this 4 is the maximum score till this point that we have got till this point. Okay. Now, if we remove node 1, then node 2 and node 3 will each have 0 connected edges. So the geek will lose the game again, because if we try to remove node 1, so remove 1, so what will be the tree structure will looking like? So our tree will look like this, and it has zero number of edges, and it also has zero number of edges. So we can see that they both have even number of edges. So the total answer or the total score for this configuration will be zero. So the zero will be the answer here, and it's also given in the explanation. And removing more than one node will also result in the remaining nodes having an even number of edges. For example, if we try to remove 1 and 3, so our tree will only have 2 as a node. So we can see that 2 has 0 number of node, that is also even. So the total score will be 0 again. Okay. So that's why our answer for this example number 1 is coming out to be 4 by this configuration. Okay, so now let's move to the approach part. So one thing that we have observed till this example number 1 is that for each node, I have two possibilities. So what is the first possibility? So the first possibility is that I can keep that node in my tree. And what is the second possibility? So this second possibility is that I can remove that node from my tree, right? So these are the two possibilities that I can consider. So we can think about the knapsack DP here, because in knapsack DP we also have uh, two choices, that is take choice and not take choice. So the thing is similar here, that we can try to remove that particular node and we can try to keep that particular node, right? So what we can do, we can just try both of these two ways, and whichever gives me the maximum answer, I can take that answer or I can store that answer, right? So we will be taking the DP approach here. So we will be making four states for every node u, right? So what will be the DP of u comma 0 will be storing? So it will be storing the maximum score when the node u is removed. Okay. So what will be the DP of 0? What will be DP of u comma 1 will be storing? So it will be storing the maximum score when u is capped with odd number of connected edges. And similarly, dp of u comma 2 will store the maximum score when u is capped with even number of connected edges, right? So in the end, what does dp of u comma 3 will be stored? So it will be storing the maximum answer or the maximum score that I can get for the subtree that is rooted at node u. Okay, so we will be following this dp approach. Okay, so the first step is to make the tree from the given parent array, because we are not given the tree. So we have to make our tree from this given parent array, right? So let's try to see the implementation also. Okay, so our function name is tree game, and we are making our adjacency a vector of adjacency, right? And it has initial size as n. So what we are trying to do, we are iterating on our parent array, and we are trying to find out what is the parent of the ith node. So how can I find out? So I can find out by using my parent array, and after that I am just pushing adjacency of par dot pushback of I, because this ith node is a parent of that particular node, right? Now after that I have made one dp array. So what is the size of the dp array? So the size of the dp array is n cross 4, right? So for every node, that is n, I will be having the four states that we have discussed earlier. So these are the states that if we remove u, then the answer will be storing in my dp of u comma 0. If we keep u with odd number of child, then it will be storing in my dp of u comma 1. And if we try to keep with even number of child, then the answer will be stored at dp of u comma 2. And in the end, the best possible answer for the subtree rooted at rooted at node u will be storing at dp of u comma 3, right? So after that, we are just making our function call for this dfs function. And what is the initial node that we are passing? So we are passing 0 as our initial node, because we have converted our node from one base in our tree from one base indexing to zero base indexing, right? So that's why we are starting from zero node, and we are passing our adjacency array, then dp, and then a. What is a? So a is the score for every node. And in the end, so what I have to find out? So I have to find out the answer for the subtree which is rooted at the node 1, right? So as we have converted this node 1 as zero base indexing, so this node 1 will be converted to node 0, right? So that's why we are just returning dp of u comma 3. Why dp of u comma 3? We are just returning dp of 0 comma 3. So why we are taking 0? Because we have to find out the answer for the subtree rooted at 1. And why dp of 0 comma 3? Because dp of u comma 3 will be storing the answer for the node u. So that's why we are returning dp of 0 comma 3 in the end. So let's try to see the implementation of our dfs function. Okay, so we have this DFS function, and what we are getting here in my DFS function, we are getting the node U, and we are also getting the adjacency array. After that, we are getting our DP array, and after that, we are having our A array, which will be storing the answer for every node, right? So at the very first, what we are doing in our DFS function, so in our DFS function, at the very first thing, we are just calling the DFS function on all the neighbors, or we can say on all the childrens of that node U, right? So we are iterating on every children, that is V, of the node U, and we are just calling the DFS function on the children or the child V. Okay. Now after this DFS function or the this for loop is finished, so the answer of the all the children of that particular node u will be stored in our dp array, right? So now we have discussed earlier that for every node we will be having two possibilities, that either I can keep that node, or either I can delete that node, right? So in the very first thing, what we are finding, so we are just finding out the answer if I try to remove the current node, right? So we can see that we are iterating on every child of that node u, and we have seen that dp of u comma 0 will be storing the value if I try to remove the node u. So that's why we are adding every child's best answer to the current state. So what is the current state? So the dp of u will be storing the answer for that current if I try to remove the current node, right? So that's why I am adding every child best possible answer into the current state, that is dp of u comma 0, right? So after that, what is the second thing? So the second thing is that I can keep the current node, right? So after that, I'm making one vector of c. So what are the values of this vector? So the initial values are 0, and the second value is minus infinity, that is very big value, right? So what does this C will be storing? So C of 0 will be storing the maximum score if node U is connected with even number of edges. And what will C of 1 will be storing? So C of 1 will be storing the maximum score if node U is connected with odd edges, right? So after that, we are just processing all of its children. So after this for loop is finished, I will be getting the maximum score if the node U is connected with even number of edges in the vector C at the 0th index, and I will get the maximum score if the node U is connected with odd number of edges at the index 1. at the index first, right? So after that I have two possibilities, or like two choices. Either I can keep that node with an odd number of edges, and either I can keep that node with even number of edges, right? So we are just storing the values or the answer for every possibility into my dp array. That is dp of u comma 1. As we have discussed earlier, that dp of u comma 1 will be storing the answer or the maximum answer that I can get if I keep this particular node u with the odd number of connected edges, right? And also dp of u comma 2 will be storing the maximum possible answer if I keep this node u with an even number of connected edges, right? And in the very end I am just finding out which of them is maximum, because dp of u comma 3 will be storing the maximum possible answer from all these possibilities. Okay, so this was the implementation of dfs function, right? So let's try to submit the problem. Let's try to submit the code. So it's passing and submit. Okay, so it's passing on the hidden test cases also. So I hope this coding and the solution is clear to you. Thank you.